Hi all, it's Brendan and I am going to do 30 Days of Solidity day number 3. Today's task is the poll station. So this is where we'll have multiple, candidates or choices, and then you store their names, and then we'll create mappings to remember who voted and also what are the tallies of the votes for each of the choices. All right, so let's begin. Switch over to Remix. I have already previously copied this and pasted it here, so I've already got a empty smart contract ready to be compiled. So what I'm going to do next is to start. So the first requirement is to store the candidate details. So I assume that's just names. So string public choices, right? And then also we will want to have the votes, right? So mapping, and so each choice will be identified by not by its name but its index within this list of strings. So 0 will be whatever's in the first name, and then 1 will be whatever's in the second name, etc. So uint 256 to uint 256. So the key and value are both the same. Votes, right? So the key is the ID of the choice, right? The ID of the choice, which is the index within this array, and the value is the number of votes for that particular choice. So a very simple sort of relationship between this array here and this mapping. All right, so let's write two functions. So this choices array needs to be populated, and then this mapping also for votes also needs to be updated each time there is a vote. So we'll have two functions, right? One for adding choices and then the other one for adding votes. So function add choice string name public, and yeah, I'll need to make the string memory, and then I will do choices dot push. Right, so I'm just adding new names into this list of choices. That's pretty straightforward. All right, so the next will be the vote function vote, and then you'll have to choose what the ID is that you're choosing to vote for. So uint 256, I guess choice ID. I would say choice index. Actually, that would be more accurate because it's the index within the array. Choice index public, and then I would say votes for choice index plus 1. Okay, so at this point I can compile that, and this would probably work, right? But there would be limitations. So for example, you could add choices in the middle of voting, which would be a bit strange for a poll station, and also the same account could vote multiple times for their preferred candidate. So it'd be a pretty unfair poll station, right? Let's just go ahead and demonstrate that. So I'll deploy the smart contract in memory into the blockchain, and then what I'll do is I'll open it up, right? So let's say I've got a choice foo add choice, and then bar add choice, right? So now I've got two choices. So if I go to index 1, then it'll be foo, index 0 is foo, index 1 is bar, because that's the order in which we added the choices, right? And then if we try to do index 2, right, we'll get an error, right, because it's an array out of index, right? So the length of choices is 2, so therefore you can only access indexes or indices 0 and 1. But in the index 2 it doesn't exist, and you'll get an out of bounds error. All right, so that's adding choices. Now let's go ahead and vote, right? So I'm going to vote for candidate 0, and then I'm going to vote for candidate 0 again, and then I'm going to vote for candidate 0 again. So I voted 3 times. Now someone else comes along, right? Switch to a different account, and they vote for candidate 1, right? And then let's say the poll is over, right? So let's see, candidate 0 has received 3 votes, and candidate 1 has received only 1 vote. And that's not fair, because the same person voted for the same candidate a few times. Another thing is that I could say add this new choice even after there have been votes, and then now I've got a new candidate with 0 votes, and that is odd, and maybe also would create unfair situation. So let's close poll station, and let's make sure that all those things don't happen, right? So firstly, let's make sure that a vote cannot happen a candidate cannot be added, a new choice cannot be added after voting has started. So there could be like some sort of admin or something like that, which has a permission to set when the votes are allowed to begin or that sort of thing. But I think an easier model, right, would be just to have the first time a vote is cast, then you close the ability, or you stop the ability to add choices. So for this, I'll use a boolean, which is just bool public has voting started, right? So I'll just do that, and I'll initialize it to false, actually. Explicit initialization that it is false. So I think by default that's what it is anyway. So then when you add a choice, I'm just going to basically say no or reject the add choice whenever voting has already started. So I'll require that the votes have not started. So I'll use that exclamation mark, which is for not, has voting started. So if voting started is false, then you can proceed. Otherwise, you'll get revert, and the transaction that calls this add choice function will not succeed. So it cannot add choices after voting has begun, right? But this will basically never trigger and never reject at this point in time, because we actually have to mark or include the state change that whether voting has started. So whenever someone casts a vote, whenever the first time that is, so has voting started is equal to true, right? And it doesn't matter if we keep setting it to true over and over again. We don't have to say if not has voting started equals true. That's a redundant if statement, right? And so this should prevent, right, choices being added after the first time a vote has been cast, which is exactly what we wanted to do. Now, the next thing that we need to do is to actually protect the vote itself, right? So we want to make sure of, I guess, a couple of things. One is that someone is not able to vote for a choice that doesn't exist. So let's say there are 2 choices and you vote for a third choice, then that's an invalid vote. So we don't allow that. So choice index is less than choices dot length, right? And choices is an array, and the length of it will be a number, and the choice index has to be less than a number. So if you have two choices, then choices of length is equal to 2, and that will mean that the only valid values for choice index will be 0 and 1. Note that choice index is an unsigned integer, so negative numbers are by definition excluded. Alright, so that will preclude voting for an invalid choice index. Now the next thing we want to check is to prevent people prevent accounts from voting more than once, right? So this requires another state variable, and that will be a mapping. So mapping address to bool public has voted. So there is now a new has voted mapping where the key is an address, the address of the voter or the voting account, and bool will be true or false. If the default value will be true, and that means that they have not voted yet, and if the value is false, the value is true, that means that account has already voted and should be barred from voting for a second or subsequent time. So require that not has voted, and we want to pass in message.sender cannot vote again. So saying person is not allowed to vote multiple times. And then of course this is redundant, it will never trigger this require statement unless we actually set that value. So we should say has voted message.sender is equal to true. So the first time that an account votes, this value will be false, and so they are allowed to proceed, and their vote will be cast and stored in the smart contract. However, the second or subsequent time that they attempt to call this, right, this value will be true. They have voted before because it has been set to true here. And so not true is false, and so this require will fail, and you'll get a revert with an error message of cannot vote again. Oh, and I forgot to put an error message here, which is cannot vote for a choice that does not exist. Alright, I think this is ready to go. So let's deploy this new version of the poll station, and we'll do some checks. Right, so let's add a couple of choices. So let's go for Elmo as one choice, and then Ernie, I guess. Elmo and Ernie. Alright, we've got two choices. So choice 0 is Elmo, and choice 1 is Ernie. Alright, now let's start the voting. So I'm going to pick the first account, right, in this list, and I'm going to vote for Elmo, right? And the second account is going to vote for Ernie. And the third account is going to vote for Ernie as well, right? So that's one vote for Elmo and 2 votes for Ernie, right? And so we can see has voting started is now true. This is a new variable. And if I try to add another choice, if I try to add, say, Big Bird as a new choice, it's going to revert, and it'll say this error message, cannot add choices after voting has begun, which is exactly what we intended, right? Now, actually this error message is wrong. Cannot vote for a choice that doesn't exist. All right, now let's try to vote for, because there's only candidates 0 and 1, right? So let's say we try to add Big Bird and it failed, but we try to vote for Big Bird anyway, right? We press vote. It'll say, cannot vote for a choice that doesn't exist, right? This still has the typos because I haven't redeployed, right? Okay, and then, so that verifies that. Now let's try to do, like, I guess the cardinal sin of voting, which is to vote more than once, right? Because that's the main thing that breaks any poll. So let's say I want to vote for Elmo again, right? Because I'm unhappy that Elmo lost the vote. So I'm going to go back to Elmo, sorry, this one, vote, and press vote, and then now I'll get an error saying cannot vote again. However, if I am a new account that has not yet voted, right, 787 in this case, and I press vote again for Elmo, and now we should have 2 to 2. So there should be, because that transaction succeeded, right? So now let's look at the votes, right? So Elmo will get 2 votes, and Ernie will also get 2 votes. And yeah, that is a pretty fair poll station. All right, thank you very much for watching. That's all I had today for 30 Days of Solidity, day 3 for the poll station.